Welcome back. In today's lecture, I will take a few minutes to highlight for you some of the important points regarding aircraft safety systems. You recall during the first week I mentioned a student who suggested that anyone who could remember and understand all the acronyms in this field should receive an A. The materials this week are chock full of them. Be prepared. When reading, take a break. Now and again, walk around, get some coffee, embrace acronyms. There is no way to get around them. However, now is a good time to listen again to my presentation on studying techniques. It is in your supplemental resources. Please let me highlight a few topics in our materials so you can tackle the topic of aviation safety systems with enthusiasm and leave this module with confidence. So far as maximizing aircraft safety, you should first understand that there are major philosophical differences between the design of Boeing aircraft versus Airbus aircraft. One company prefers simple pilot-engaged systems, and the other relies upon complex computer-monitored systems. Each have their own advantages and disadvantages. You should understand them and be prepared to support an argument for or against these philosophies. Next, you should understand that all commercial aircraft are built with double or even triple redundancy in every important system. This includes coffee makers. For example, in addition to the normal pumps that control the hydraulic brakes, there will be accumulators that store nitrogen to operate the brakes in case the hydraulic system fails. Likewise, there are multiple flight computers. In case one fails, another is ready to take over. On the other hand, reliability and increased power have allowed the designers to reduce the number of engines on aircraft, yet still have the same degree of safety when flying over water. Originally, the regulations called for a 4-engine minimum, then 3, and now 2. The reduction means today's aircraft weigh less, have better fuel efficiency, and have better aerodynamics than older aircraft with more engines. There are two specific safety systems I want to mention. The first one is called TCAS, which stands for Traffic Collision Avoidance System. TCAS is a system that's now required on all commercial airliners and is a system which allows each aircraft to communicate with the other. If there's a collision hazard, the two TCAS units will work together and agree to tell the pilot in one airplane to climb and the pilot in the other to descend. It's been a tremendous safety enhancement and has prevented many mid-air collisions. The other is called GPWS, or Ground Proximity Warning System. This device is designed so that if the aircraft is descending prematurely or flying over rising terrain, the ground proximity warning system will alert the pilots in the cockpit. Thus, GPWS helps avoid the likelihood of having what is known as controlled flight into terrain, or a CFIT accident. The last thing I want to highlight for you today is the human-to-flight deck interface. Designing a safe aircraft requires more than just accommodating tall people and short people, or physically strong people and not so strong people. It has to do with understanding how people feel and interact to the hundreds of switches, lights, and levers. Interestingly enough, designing safe aircraft for humans also requires consideration of the cultural differences between pilots who hail from different parts of the world. What system interfaces are placed on the flight deck is just as important as where the display is that controls the system. What is the color and shape of the display, and where it is in relation to another system that it might be confused with. Two common examples of this type of human-to-flight deck design are having the landing gear lever being shaped like a wheel and the flap lever feeling like the trailing edge of a wing. So today in our discussion of aircraft safety systems, we learned how Boeing and Airbus take vastly different engineering approaches to accomplish maximum aircraft safety. Then we focused on a few specific aircraft safety systems and how good flight deck interfaces permit minimum human error. I hope you enjoy the learning opportunities available this week. The content is important and can contribute to every aviation professional's safety and satisfaction. Good luck, fly safe, and be safe.